Oh, well, just needs it a little more higher. Okay, hi everyone, thanks for coming. So my name is Tal, and I'm gonna talk about Serverless Security Top 10. It's based on a OS project. I'll show that in a few minutes. And we encourage everyone, it's an ongoing project, so we encourage everyone to participate, to get involved, maybe share some knowledge. If you have. If not, this is the place to be. That's it. Let's start. Okay, so I've been working about 15 years in the InfoSec, mostly in AppSec, everything, IoT, web, mobile, serverless, whatever, you name it. You can follow me one of these. I'm working currently the startup based in Israel called Protego Labs. We have a solution for serverless security. So everything that you're going to hear in this talk, we're trying to defend against. So I know most of you, at least most of the people that I talk with, doesn't have any knowledge about serverless. And when I say, "Do you know anything about serverless?" and they say, "Server what?" So how many here have heard of serverless, or you just okay? How many of you have actually deployed, let's say, a Lambda function or an equivalent? Okay, more than I expected. That's great. But in every security conference that I go to, I start with a few slides about what is serverless, because it's different and people don't know it. It's kind of a new technology. So I'll start with some basics about serverless, so you'll understand what are we talking about, what do we have a different top 10 than one we used to, what are the challenges in security, and then we'll dive into the top 10. So let's start the evolution of the cloud, or the deployment. So we started back then in the 80s, 90s with the on-prem old application where everything was in the organization's servers and computers and data centers. And we moved in. I'm not going to talk about everything, but we all know containers, right? So I'll stop for a second in containers and say containers were great because most of the things that we used to do when we develop a program, an application, we don't need to deal with. But we still need to do some things there, like monitoring and patching the OS, make sure that the container is up to date. We have to scale it. And that's a lot of operations and also a lot of security, which we'll talk also in a few seconds. They're pretty close here. So when we move to serverless, hope we'll have also a few laughs that will disturb them. So when we move to serverless, we're really taking out everything apart from the code of our application, so the business logic of the application, and a few minor configurations which we can still control in the application. Most of them we can't, which is great for some companies. Let's say you're a startup and you just want to start. You have an idea and you want to to start developing the idea. Just the thought of the fact that you will probably have to buy a server, then try to install the operations, deal with the security of the operation system and scale it and everything. Just that can really change the fact that you will start doing something or not. So when you have serverless, you can just write code and that's it. It works. Let's get familiar with the providers and the players. So the serverless main frameworks are the AWS, Azure, Google, so GCP and IBM. These are the main. AWS really controls everything though, about 45% of the market of the serverless. But these are the complete frameworks for serverless, but there are a lot of companies that now understand that this is the future of computing or cloud computing and start giving away functions as a service. So it's called FaaS, function as a service. So all these companies, some of them very big like SAP or Huawei or Oracle, they know they are giving customers the ability to build functions in the cloud, not dealing with any servers, just code. who are using serverless. So these are the big companies, maybe the first adopters. So you can find big companies like EA, Netflix, Capital One, Coca-Cola, etc. But there are a lot of companies coming into that. This is only from the last presentation from the reInvent in AWS. So these are only AWS customers. There are many more, of course, and so not everyone, but a lot of companies understand the power of serverless. Let's just see where we stand. So this is why most people yet don't know it yet. So if I take this is Google Trends, right? I wrote serverless computing. It's a topic there, and from 2016 to 2018, I left the couple months, the last month, because it gets the information late. So you can see it's in a constant rise, and probably will continue to do so. But when we talk about security, so I'll just do serverless security, and well, not really. And there are two here, and I'm pretty much the first one is me. So just one more search for serverless security today. But just so you'll really understand where we're standing, let's just write Docker, for example. That's not the actual software, but yeah. So not really. It's really new. You can see here that it's very new, and they're giving the option to write Docker software, I think, because it can also be but not. Anyways, it's going to be the same. So it's very, very low compared to other technologies. It's very new, so not a lot of people talk about it yet, and we're trying to make them talk about it. The reInvent, last AWS reInvent conference, they mostly talked about serverless and security, so that's a good start. A few serverless basics. Yeah, I went full all in with the Pirates theme there. So there are a few basics why to go to serverless. So the first one is infrastructure. It scales to zero because you don't deal with infrastructure there. Everything is given by the service provider. You just need to know how to use it the right way. And they have the pay-per-use model where you only pay for what you consume. So even if you write up a complete application, no one ever used it, you won't pay for it. It will run, it can execute, you can execute it, you can test it. But if no invocations will come to your code, then you won't pay for it, or you pay a few dimes for that. So that's also good for startups and for other companies that wants to reduce their costs. The second part is architecture. The difference between regular applications and serverless is that the serverless applications are more tend to be microservices focused. So you write a bunch of functions instead of a whole brain of your application. You write like 100 functions. I'm just throwing a number here, but like 100 function, each one will be like 100 lines of code. Each function will do its own purpose. So just process this, upload this, download this. Each function will do its own purpose repeatedly, and you won't run the whole brain of the application inside one function. You are also limited for 15 minutes, I think. And the last part is operations. We discussed that you don't have to deal with scalability here. That's one good thing that you have when you go to serverless. But it also allows you to, of course, develop more rapidly. So you can just write up new functions, new code, deploy it in one command line. You have an up and running application, and it's very good for companies wanting to get more features out fast. Let's do some pro and cons for the technologies. Right, that's not the one. Though I like the endless RAM. Okay. So, there are, of course, some pros and cons. First one is no servers. So, it can also be a con because you don't have where to control your environment. You don't control it, really, just your code. So, where do you deploy firewalls, IDS, IPS, whatever you want, name it, monitoring for the network? You cannot deploy that because you don't have a server, so you don't control that. There is no perimeter. We'll discuss that later. So there is not only one entry point to your application. In the monolithic application, we used to have the network entry like HTTP or any other TCP protocol, something like that. It's not like that anymore. The environment is more event-driven, and I'll discuss that in a second. More complexity because again, you have multiple functions, and there are a bunch of things that you have to deal with for security for each of the functions separately, and we'll discuss that as well. And of course, the high velocity is good for the development, but for the security is a challenge, because if you have a security team that has to keep up with the pace of new code running into development every day or two, then it's hard. In the pros, you don't have to deal with servers. So that's also a good thing. The fine-grained environment, so if we know specifically what each function needs to be doing, we can really fine-grain the environment. And I'll show you later how you can really, really reduce the attack surface if you set the function correctly with its permission. Transparency. So we discussed containers before. So when you get a container out of the Docker repo or whatever, you don't really know what's in there running or what's in there in potential to be running or open. So you have to investigate. Maybe there are some ports open, maybe some processes running, unpatched processes. You don't know, and it can cause a big security issue for you, for your application. Whereas in serverless, you don't deal with that. It's being taken care of by the providers. And the ephemeral environment, I'll discuss that later, but just so you understand how things work. So when you call your application, either from an API gateway, like a request, so a gateway, an API request, or through an email or whatever, it triggers a function code. And when this code needs to be executed, Amazon or any other provider will spin up container for you. You don't deal with that again. They will execute the code in that environment, closed environment, and when it finishes, they will kill it. Okay, and we'll also understand why they kill it later. But you don't control over the environment after the code has completed its task. So once the code is done, you have no control over the same environment, the same container, what's left in there, what you want to do. So you can only do that while the code is running. So in this talk, I will go through the OWASP Serverless Top 10, another project that I started a couple of months ago. It's getting pace. A lot of involvement. People want to get involved. You are very welcome to do that. We are looking for people to get involved. The current state of the project is that we published an interpretation of the OWASP, the original OWASP Top 10. So we took the original OWASP Top 10, and then we just went one by one and described why is it different from monolithic to serverless. What are the attack vectors? Why the impact is different? What is the impact? What are the weaknesses? How do you defend that? And you can see that there is a very big difference in the type of attacks and defense. So the attack is still there mostly, but it differs. And the goal, of course, is to have a serverless tailored top 10. We're currently working with some companies that have uses this technology, and of course with the providers as well. Links you can get later. So let's dive into the top 10, the interesting stuff. So the first one, and as it says here, order may vary. We'll keep the order of the top 10 just for ease of use. First one, if you go to the top 10, is injection. We call it event injection. Great. Because, as I mentioned before, your code is event driven. So if before we had an API gateway to our application, so a request would trigger a specific function in the code or a specific file in the backend, then here it's a little different. It can still work like that, but you can trigger functions with various of things. For example, you can trigger functions with emails. You can trigger functions with MQTT. notifications. You can trigger events if a file was uploaded to a cloud storage, let's say. This will trigger a function, internal function, so you can process the function. So it's an indirect request to an upload storage, and indirectly a function will get will start running based on this. It can also be for tables. So if you have a database, SQL, NoSQL database, you can trigger functions based on modifications into these tables. Again, if someone changed the table, entry was changed, you want to run a code that will process that, then you can write up. So that's different. You don't have one entry to the application where you can put, okay, I will put everything, all my security controls in the entry point, load balancer or whatever, and from there on, I will consider the input maybe safer. Whilst here, no, you don't control the entry point to your functions. Sometimes you have some controls, of course, if there is an API gateway, you can put it there, but it's just that. So everything else, you might not control the entry point. Of course, what you can do with the injection depends on the function capabilities, and we'll discuss that later. So I said before, one entry point, multiple entry points, so you can process analytics indirectly, so not a direct request to your function, but you can run also scheduled tasks, cron jobs, etc. And before. So this is an example scenario. Someone can send an email with his CV attached or whatever. The email reaches the server, it's not our server, but a server, mail server. And then AWS will send a notification, SNS, to our function, so we know that an email was sent. Maybe we'll go grab this attachment, the CVE, and process it, or do whatever we want with it. So if the function goes to this email, and I don't know, get the attachment and process the file in the environment there, we can actually run code there, maybe. If it's insecure, if there is no input validation, because we thought, oh, AWS sent us this notification, so there is no actual direct call to the function, someone can either just run our code, or it can actually send a malicious code there, and we'll see an example. But now I'm going to show you, start off easy with an API injection. So burp, you are more familiar with that probably, and I'll show how that works. So let's see. We'll try the live version. If not, I have a backup. So I'll introduce you later to this application as well. It's a damn vulnerable serverless application. It's running online also on serverless.fail. We have it running there for a month, maybe less. And here you can purchase video games, old video games, very cool. So let's start anew. So I'll just take run page, okay. Check out. It's a vulnerable app, right? Okay, shipping address. Now I have to enter my billing address. Of course, for this demo, I will send non-valid payment details. Of course, it will not go through because the credit card is invalid. Okay, so now when I go to my orders, I can see here that I have an order with a payment failed status. Okay, I'll just grab this ID here, and now let's hope it works. So the function that is running and gets the API call is vulnerable to code injection. Okay, this is the injection part. So it's vulnerable to code injection due to a vulnerable library. So nothing bad the user actually wrote, the developer actually wrote. It just uses a vulnerable library. Okay, and the function gets just an action. So if I go to burp, we'll normally see in the history regular calls will be just action inbox or action up shipping or action new, right? These are new regular requests, and here the function is vulnerable to code injection. So I entered this payload you don't really need to understand how it's what the exploit is. It's online. I mean, you can find, if you know the vulnerable library, you can just find the exploit for it online. But you can see here, why is it different than anything else? Because this application also has a few back office functions which are not connected to the world. Let's think of it as a function or a code that runs on your internal network, and it's not connected to the online world. So no one can actually invoke it unless they're in the network. But here is a little different, because the function that I'm calling, which is the API gateway function, has permissions to invoke different functions for the normal use. I mean, to invoke new, create new function, create new order, process order, but it's not limited within its permissions. So I can also run something code that looks like this, var require AWS SDK, and then new lambda, and then I can call an admin function which is not connected to anything, but I can invoke it directly. So I can do lambda invoke. This is AWS serverless code, so you need to get familiar with the environment, what you can do, how you can use leverage the AWS SDK. And then what I will do is that I will change the order ID here. Let's hope it works. With the order ID that I got, and now I'm doing here action update on my order with a random token and a fake address and a different status, which is this status. And when I get this, I get an unknown action. Of course, it's an unknown action, but when I get here, refresh the page, I can see that the order was paid, even though the only way to get it into a paid status is to have an internal access to an admin function, which I don't have, but through the injection code. So you understand this is different than the regular monolithic application, only because it's a different type of injection that we have to do in order to get things running there. And you have other things to worry about. Okay, let's go into the second one. Of course, we have 10 to go, so I cannot go too much into each one. So the second one will be broken authentication. Another thing that's important to understand is that functions, because of this nature, of ephemeral nature, they are stateless. That means that they know anything that happened before or after them. They just run code. So that means that it's hard to maintain authentication or access control for throughout the application without having some other service integrated with our environment. So you can use if you're using AWS, you can use AWS Cognito, for example, which will high-levelly control everything with a token. But if you have some internal functions, so you don't use Cognito users to invoke them, how do you control the environment and that the authentication? And that could be tricky. So for example, this is an example scenario where you have some internal development cycle where you get notification via email or just a normal notification when someone is trying to commit a new code or deploy push code to the master or something like that, which is invoked also via email. So if someone can just send an email to that address, I don't know, it's an internal address, but it's still an address. And if someone can, from the outside, can send an email to that address, it will invoke a function, even though it was for good purposes. Here I can invoke a function, an internal function, without doing everything, all the process. So you need to understand not to trust everything because it's internal use only. The third part is sensitive data exposure. It's the same thing in the cloud. So when you do use the cloud for your application, there is always the risk of having your code somewhere else. Although even now the government understands it's not less secure than in your servers. Specifically because I'm not going to advocate for cloud now, but you have big companies that try to deal with it, whether your companies might not have all the resources to make sure their server is secure, but that's not the topic now. So there are specific serverless scenarios for sensitive data exposure. For example, I told you that when a container spins up and when it ends, the container is being killed by AWS. That's not entirely true. They kill it only after a few minutes if no one called again the same code. So these containers are read-only file system apart from the /temp directory, which wherever you want to process file and data, you do it in the /temp directory. But because companies and developers think when the code ends, the data dies with it, it's not true. Because if I shoot a request that will either accidentally, if there are millions or hundreds of them, hundreds, thousands, or millions, whatever, or just even two requests, one after another, there is a good chance that I will land, even though I don't control that, I will land on the same environment because AWS wants to control or to keep up with the performance, so they leave their container alive for a few more minutes to see if something comes up again, and then I can land on the same environment, and if I have a code injection or a command injection, I can actually get the data from the /temp directory. Other thing that is very sensitive and people tend to do is to put sensitive information in the environment variable. So this is the actual way to pass data to your functions. So if you want to store, I don't know, API keys or something else, you put it into the environment variables. And then the function knows how to get them. But if they are not encrypted, I might be able, again, to land on the function, have a code injection, and send them up to my evil server. Another thing that is very problematic is it's been there before serverless, but open buckets. So S3 buckets, you can upload files, and they have configuration whether they can be read from anyone. And many companies and many buckets are left open. So there is actually a website called White Hat Warfare, I think. Open. It's the showdown of buckets. Something like that. It's called White Hat Warfare or Warfare White Hat, something like that. Oh, Gray Hat. This is why I couldn't find it. Gray Hat Warfare. Yeah. Public buckets. And it's like Showdown for IoT, but for buckets. So you can just go into random buckets and find passports of people. I don't know why they do that, but you can just go and see companies leaving open buckets where all the user's information are there. Some buckets can be open if it's static information, website information, but some of them are very sensitive if they are not secure, configured correctly. And the last part, and we'll see in a second, is that your source code is actually in the environment. So when the provider runs your code, it actually lives in the environment. So there is a file with your code running, and you can access it. So stealing, so this is also something, and we'll see how we can steal that. So one thing would be, what would you do as an attacker? What would you do in a serverless environment? You will maybe try to steal the function keys. The keys are stored in the environment variables built in by AWS. This is how it works. So if you get hold of your environment variable of a function, you can do in the environment or in the account, not in the environment, in the whole AWS account, whatever the function can do with these keys. And I'll show you a demo how I do that in a sec. Number 4. Okay. Number 4, XXE. Again, it will be pretty much the same here. Maybe you will run under a VPC, so you won't be able really to get things out of the environment. Built-in libraries, not as are secure, but most of the built-in environments in the Lambda, of course you can import whatever libraries you want, third-party, open source, whatever you want, but the built-in libraries are configured securely without letting you go to having XXC. Of course you can, if you're very good at it, you can make resolve entities true, load DTD true, no network false, and then you can have an XXC in your application. And then this is a code, a regular code. And so the normal, what we're used to would be something like that, right? So system file etc password, I want that file. Is it important in serverless? No, no one cares about etc password. It's generic for the container. You cannot do anything with it. I can actually give it to the attacker if they want. I actually did. I put it online somewhere as one part of one of my talks to show how it's not important. But what is important? What can I get from the environment? Any idea? Yeah, environment variables, maybe, yeah, they're not files, but maybe I can get them. Tricky. What files? I just mentioned that. Your code is there. So I can do something like that. If you ran Python code, var task handler or the function name .py will get me your source code. So backend code through that. And this is how it would look in the logs. Of course, it's not the same as getting it out of the environment. Depends on the configuration, of course. So you can see the code here through the CloudWatch logs. Okay. Number 5, broken access control. So again, it's a little different from what we used to. I'll say that access control was before serverless was more infra level, not entirely, because you can control also in the app level, but let's say you want to have a permission to the database or to a resource or to, I don't know, like another server or something. This is more an infra thing before, where you have you configure users for your database or the keys to your environment. Where in serverless, specifically for AWS, others are trying to pace in with that as well. Each function has its own permission in the account. So think about that each, you need, as a developer, you actually need to go through, I think they have more than 5,000 actions that a function can do in an AWS environment, and you have to choose specifically what you want to for that specific function, which is could be very, very good if you can maybe automate it or get the least privilege, but it's very hard to do manually. How would I know? If you write a function that needs to, I don't know, process a file, and you go to the AWS documentation, they will give you the least secured permission as the example, just to make sure your code will work. So they will use wildcards, etc. So you can do whatever you want. Just let you see that your code will actually work. So developers are actually copying from them, and it's get us into a very insecure state. And so the extreme case, if a function is vulnerable to code injection, command injection, any other thing, and has very high permissions in the AWS account, you can actually control an account, an entire AWS account. But I'll show you a very simpler example so you can see how it actually works. So let's say I have this code, very not important what it does, but it goes to, let's say it gets a notification from an S3 bucket, which is a cloud storage. Then it goes, take the file and reads it. Okay? So I tell the developer, hey, this is what you have to do. Go find the specific permissions that the function needs to run. And the developer goes to the documentation or any other Stack Overflow or something, and he gets this permission policy, which is how it looks in AWS. And it's okay, it will work because the function now has permission to do anything, so wildcard on the S3 bucket service, not the bucket, And the resource would be any S3 bucket that the account has permission, because they run inside the account with the permission of the whole account. So this code needs to go to my bucket and get file.jpg, but it can, or it could actually access any cloud bucket in the environment and do not only get, but also write, delete, create buckets, delete bucket. It can do everything in the account that relates to the AWS3 service. So you go and say, okay, you don't need all that permission, maybe limit the resource. So now the function can do anything, but specifically on these bucket files. Okay, so my bucket is the only bucket that the function can touch, but it can still delete it. It can still delete the files in it. It can still create new one. It can change permissions to files. So the least privilege for this specific code would be something like that. So not only you can only touch my bucket, but you can only do get object. So the function, even if you wrote the most insecure code and everything is open, no matter what, your function won't be able to do anything else than get as a file or any file, but only get from this specific bucket. So think of it, it's still a problem, but you really reduced your attack surface into a very small piece. And if you could do that for each function, before even touching or writing a secure code, do that specifically for each function, you can really have a secure environment or a least privileged environment. The problem is how you do it manually. You probably have to automate it. Let's see a demo of how it looks. Sorry. So, I have a function here. Okay, so I'm using here serverless framework. They probably were the first, so they stole the name. So they called serverless, like the technology, but it's a framework for working with serverless. So when I deploy a function, I usually just do serverless deploy, and according to the file, to the configuration file, it will deploy the function in the environment. But let's have a look. So I think I have it open. Yeah. So this is the configuration file. It's not important. What I want to show you is the role for the function. This is the policy for the S3 bucket. The function touches S3 bucket. But the permission here, as you can see, is action DynamoDB. Oh, sorry, not an S3 bucket, a DynamoDB table. Okay, so it's just a NoSQL table, a DynamoDB wildcard. So you can do anything into the in any DynamoDB. Oh, sorry, in specific in this table. Okay, but it can still do anything into this table. So the function happens to be vulnerable. And happens to be right. So I have a chatbot here, which answers to my messages, and this chatbot. Never mind. So this chatbot just takes my my message, interprets it according to some dummy logic, and answers accordingly. And it's vulnerable to the same code injection that I had before. So now what I'm going to do is that I'm going to take a payload here. And you can see, again, it starts the same because this is how you exploit it. But this time I will do something different. This time I will do require AWS SDK as before, but also require HTTPS. And then I will do, the most important thing here is I will do a DynamoDB document client scan. So if you know AWS SDK, scan will give you everything that is in the table, even though the function only writes your messages to the table. It only needs to write your message to the table. But when I shoot that, and also later I want to see the results, so I will use the environment variable of the function. So you can see process.env channel, process.env username, process.env boat token. I don't even need to know them, but they live in the environment. So when I send this, I get everything that's inside the DynamoDB table, and I also changed modify the icon. Because the function has unnecessarily permission to read the database. So I can do whatever. I can actually delete the database if I want, but I got everything inside. So let's see how it would change if I only take this and I do, this is the permission just to write. So this is everything I changed, so few 7 characters, and then I will do serverless deploy. I will redeploy the function. Let's see, it's still fine. So, hi, are you there? Great. So it's still there. I'm just looking for it to finish here. I think it's already running. Let's try. See that it's responsive. Yeah, okay. And it's done here. So now I will shoot the same payload again. And if I'm lucky, nothing will happen, because the provider now blocked me from trying to read the database, because the function itself doesn't have the permission to do that. So as secure, let's try again just to see. Nothing happens, and it's still responsive, so it's still working. Okay. So few characters, and I change my security posture. Another issue that we have, number 6, is a misconfiguration. They're actually all tied up. Let's try to wrap it. This is the last demo. So it's very hard to do the configuration thing manually. Think about it, for thousands of functions. If you go to Netflix, I don't know how functions they have, thousands of functions. There are a bunch of other security issues, like timeouts that you can configure to your function, denial of service, denial of wallet. You can read all of them in the report. But let's see another demo. So I have, I'll show you a demo here. Let's use just a video, it will be easier. If I find it, I think it's it. Okay. So this is the application. I complete purchase here. These are good credit card numbers. So I will complete the purchase. And when I go to orders, of course, it's paid. And after 2 refreshes, I will see that it's already processed. And when I'll go to my inbox, I will get my invoice. So the invoice link has a link to download the invoice. And you can see that the invoice sits in an S3 bucket. And you can see also the structure of the files in it. And this specific function is vulnerable to, a different function, not the one that I directly send anything or got the link from. There is another function, internal function, that takes this my order from somewhere and creates an invoice for me and uploads it here. So now and it's vulnerable to command injection. So now I will run a code that you can see that what I do is does AWS S3 CP, which means I upload a file, and I'm from my computer at home doing that, so I'm not related to the server anywhere. And you can see that the file name will be something evil, like curl into ngrok my computer, base64 the environment variable, so end pipe base64, and then some permissions, so the file will be open. And the profile is the profile of the hacker from home, not related to the account. And you can see in the upper screen that I got a request. I copied this payload that I got in base64, which are the environment variable. Base64 decoded, and I get the environment variables that I showed you before. But it's not. It doesn't end here. Now what I'm going to do is I'm going to copy. I'm going to copy the credentials in the environment variables. And then I'm going to run again from my home, but with these keys. some commands into the account. So you can see S3 API list object into this receipt buckets, and I get all the files that are in the bucket from home with the keys of the function that I stole. I can also do list buckets and see all the buckets in the account, and I can actually get all the files from all the buckets within the account. So that's a real mess for the company, just for having one function, small function, vulnerable to command injection. Cross-site scripting, number 7, they still exist. Again, they can come from different locations, like instead of regular request response, they can come from emails, they can come from SQS, SNS, whatever. Insecure deserialization, again, environment are running Python and Node is very common for easy deserialization because they are just interpreted, not compiled, but you can also do that. This is code we found in the wild, GitHub, and you can just build a payload. Only the payload will have to be different because, again, you can steal the code or you can steal the environment variable, and you don't really do an RCE or something like that. So you need to understand the serverless environment. Number 9, vulnerable dependencies. So the microservices type of architecture is really big for small functions, but for your small functions to work, they usually bring up all the internet. So as a dependency. So you need dependencies to process, you need dependencies to I don't know what, and you bring that as a line, as an import something. And if the function, the library is vulnerable, then your function can be vulnerable too, and your application could be exploited. Most of the examples that I showed you, apart from the last one, are actually just due to a vulnerable library, and you can see the open source as well online. They were much funnier. Okay, the last one is the insufficient logging and monitoring. Again, it's not that it's not available, but it's not yours, so you cannot just deploy a network monitoring into your network environment because you don't control that. So you'll have to understand the service provider, what it offers you and how to get information from it. So you'll have to interact with different of services like Kinesis or CloudWatch or any other log system and try to process it to understand what's happening into your environment. But it's hard because you need to understand it, and also you need to understand how you get your security out of it. And it can be very, very difficult to understand how you get security information out of it. So of course there are a bunch of solutions out there. Mine's is the best, but there are some other competition that are very good, also doing a good job. Not as good, but good. If you want to learn more, I do serious blog post series, deep dive into serverless attacks, where I take each of the top 10 and I actually deep dive into it more into details. I also show demos of how I hack it, how you can steal information data according to the vulnerability, and yeah, this is a continuous, and now in number 3, so you can try to follow them if you want to. The last thing that I will talk about is the DVSA, is the damn vulnerable serverless application. It's also open source, so it's a vulnerable serverless application, 100% serverless application with about 70 resources that you can really break out, and it's available online, serverless.fail. It's also available as open source on GitHub. It has a Twitter that you can actually hack if you know what you're doing inside the application. And it's also now part of the AWS Serverless repository. So if you have an AWS account, all you have to do is click deploy. And after 3 minutes, you'll have everything up and running in your account. Do not install that into your production account. Really, it will really allow people to do whatever they want there. So just deploy that somewhere into a sub account or something like that. And it's cool. It has also lessons, so you can see either videos. These are only the beginning, but you can see lessons of how to, yeah, it doesn't go anywhere. I found a bug. Cool. But on GitHub, if you go to the GitHub, you can go to the, oh, you know what? Actually, also here. If you go here to lessons, you can see that you have lessons. These are only minor documentations. There are a bunch of other vulnerabilities that we didn't document. You can see how to hack it and what you can do, so you can learn from it and also participate. We'll love to get involvement. This is an OWASP open source project, so we'll love to have you. And riddles, questions. Thank you. Any questions? Yeah. I'm a little deaf, so I'll try. Okay, come up. Thanks, everyone.
Thanks, Cal. Thanks so much for sharing. It was great.
Thank you.